I'll just get started. Everybody who did it already. You can make a table. And you can use -2, -1, 0, 1, and 2. And this is where you'll start to remember doing this. 1 over 2 squared is 1/4. This is 1/2, and 2 to the 0 power is 1, 2. Okay, and we talked about, when we originally graphed this for the first time, we talked about how the y values will never come out negative, and they'll never equal 0 perfectly either. And this is when I introduced the idea of an asymptote. So -2 1/4, just really close to 0, and then 1/2. 1, 2, 2, 4. There it is. So this should be, if you participated in the video from March 10th, this is it. The domain and range of this is x can be anything. It's all real numbers, and the range is limited to values greater than 0. And I said I really want you to put a dashed line in for the asymptote. The asymptote is at y equals 0. Alright, so in the video is the only time I've ever talked about how you find the inverse of an exponential function. But we have learned inverses before. Can anybody recall how to find the inverse of an equation? Switch x and y and get y alone. Good job. Okay, that word inverse, your brain has to know, means to switch x and y and get y alone. So when I switch, I get x equals 2 to the y. So now I'm really left thinking, how do I get y alone? You know? You got it? Yes. Okay, so if you want to write steps, I did in the video. Step 1 is to switch. Step 2 is to convert to log form. And the reason you convert to log form is because logarithms solve for exponents, and we need to solve for y. So the only way to solve for y as an exponent is to put it in log form. So it would be log base 2 of x equals y. That's converting. So number 2 says find the inverse. Done. This is the inverse. The inverse of an exponential function is a logarithm. Now we have to graph it. we're going to graph y equals log base 2 of x. We'll make a table. There's a neat strategy about graphing logarithms. So I'm going to tell you the long way, but I'm going to also tell you a shortcut. So hang in there with it. So think about what you want in this argument spot. It's easiest with powers of 2. Like, if there was a 4 here, I'd be thinking 2 to what power would give me 4, right? If there was an 8 here, I'd be thinking 2 to what power would give me 8. Okay? So that takes up a lot of big thought. Another strategy is to actually fill in the y first. And consider the exponential form. Okay. So you're going to do like 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 squared is 4. That's all of them. We could keep going, but did I miss one? I missed 2 to the first. 2 to the first is 2. 2 squared is 4. So this is a really nice moment to stop and reflect on how inverses work. If you compare the table in number 1 to the trickier log table that I just made, the x's and the y's are just flipped. And so when we learned inverses, we actually did a triangle. We plotted a triangle, and I told you to switch x and y, and then you graphed a new triangle, and it was reflected diagonally. Well, this is the same concept. We have a table. If you switch x and y, you get the inverse of that, and that's the graph of the logarithm. I'm going to graph it back on my first coordinate plane, so you can as well. If you want to graph your log right here on the same x and y as your exponential equation, that's a good idea. Do you want me to write these in order first? You might be a little confused. So it's 1/4 negative 2, 1/2 negative 1, 1 0, 2 1, and 4 2. Those are the lower terms. And there's your logarithm. It's very cool. It's the exact same curve, reflected diagonally. If you would like to put in your line of reflection, it'd be really nice. All inverses reflect across y equals x. So and the range is then all real numbers. So it's the domain and range of an exponential graph switched. Who's got a question about this? Maybe in your homework you had something different from weeks ago. You have a question? This is domain and range of the log here, and that's domain and range of an exponent there. So you want to identify the transformations. Yep. So the parent function would be the base 4, right? And so this transformation would be a horizontal translation of 3, positive 3. And a vertical translation of 2. So for my table. So you're going to make a table for the base, for the parent function base 4. And then in order to shift it right 3, you're just going to add 3 to the x's. In order to shift it up 2, you're going to add 2 to the y's, and then you're going to graph those outer pairs. That's the easiest way to graph a logarithm with translations. All right, so for logarithms, sometimes it's easier for students to just plug in the y's. For logarithms, you can use these same y points for all of these parent functions. Okay? So logarithms are actually a little bit backwards in that we're gonna know the y values. All your exponential graphs, you can put these for x's. For all your log graphs, you can put those same ones for y's because they are inverse. Okay. So if I consider the exponential form of this, it's 4 to the y equals x. So this is like too wide. 4 to the negative 2 is 1/16. 4 to the negative 1 is 1/4. This is obviously the trickiest part, working backwards like that. And I mean, the more you do it, you think, oh yeah, well, if there was a 16 here, you're thinking 4 to what power is 16? 4 squared. All right, so we're going to add 3. So if I wanted to add 3, you have my full permission in this problem to do a mixed number. 1/16 plus 3 is 3 and 1/16. Fine. That's the easiest way to do that. Right, 3 from 1/4 is 3 and 1/4. Subtraction's a bit harder. You can you'll have to get a common denominator. 1 plus 3 is 4. 4 plus 3 is 7. 16 plus 3 is 19. Those are your x values. Add 2, and here are your y values. So I think it would be really nice if you graph the parent function, like these original points, and then graph the translation as well. I'll show you what I mean. Is there any more? That's the last one. That's the last one we're doing. And then I'm giving you a handout with graphs on it, so you have an easy place to graph. So 4 to the -2 is 1 over 4 squared. Negative exponents lead to fractions. And that's 1 over 4. Show more work than I did. Just make this bigger and show more work, and then it might be easier. You're good. Good question. Let me make my graph. So my x's go from 1/16 all the way up to 16, and in this case 19, and my y's just go up to 4. From the middle of the table. Now I'm going to graph the outside order curves to show the shift, right, 3 and up 2. Right, 3 and up 2. I'm going to add something to this graph. It's going to make it. a little bit better. The asymptote is at x equals 3. Whereas the parent function's asymptote is at x equals 0, this asymptote is at x equals 3, shifted right 3. So the domain and range of this blue graph, the domain is x greater than 3, and the range is all real numbers. So if you want to write this down, log base b x minus h plus k, this value here is the value of the asymptote as well as the value in the domain. Okay? That'll help you with that domain and range a little bit. So I'm going to give you a worksheet. First of all, we're Friday summer, but I'm going to give you a worksheet, and you're going to do this table on the worksheet. You'll have to do it on your own paper. There's not enough room. But you do the base function, and then you do the shift left, right, up, or down. Okay? Before I give you a worksheet, let's go over homework from Friday.